Okay, guys, we're going to continue on today and learn inclined planes with pulleys. So last time we talked about inclined planes. So we know the physics of an inclined plane, but we're going to combine it today with pulleys. And we learned pulleys a couple of class periods ago. And so now we're going to combine a couple of skills that we already know about and see how it would work in a system set up kind of like this diagram here. So we have a block on an inclined plane hooked to a string that goes across the pulley, and the other block is hanging off of the pulley right there. And we're going to see, I'm going to ask you a couple questions with these systems. Which way is the system going to go? Is it going to go up and down or that way, or is it going to come up and down to the left this way? So there's a couple of things that we are going to have to compare here in terms of forces. But also I'm going to ask you the acceleration of the system and the tension in the rope. And so we've done that before, but now we're just going to combine them and use inclined planes and pulleys in the same question. All right, here's an example problem. It's in the guided notes, so please be following along in your guided notes and write down everything that I write down. Okay, these free body diagrams are going to be the same for all of these questions, so if you know how to do this example problem, you should be fine on your practice problems that are coming up. Okay. All right, let's read it. It says, in the diagram below, block A has a mass of 22 kgs. I'm going to put that in this block. Block B has a mass of 18 kgs. Let's go ahead and put that one in block B. If theta is 35 degrees, so I'm going to put 35 right here, and the coefficient of kinetic friction is 0.25, find the acceleration of the system and the tension in the rope. Okay, so if this system is going to accelerate, how do we know which way it's going to accelerate? Well, we're going to have to draw the free body diagrams and figure out the force that's pulling it down the ramp here. And we're going to compare that with the force that's pulling block B down, which is its weight. But there's also another force we need to consider, and that's friction between block A and the ramp. So there's three forces that I want you to be careful about finding, and that's force of friction here, force of gravity pulling it down the ramp, and then also the weight of block B. Okay? So let's go ahead and draw the free body diagram. Let's start with block A. What is the easiest place to start, guys? Force of gravity. Okay, comes straight down. Force of gravity. Then what I like to do is draw in the normal force here. The normal force comes perpendicular to the ramp, so it should make a right angle right there. Now if you've got your normal force, what you can do is just continue down in the same line, and that's going to be your force of gravity in the y direction. Okay, if we come across and meet up and make a triangle here at a right angle, now this one is force of gravity in the x direction. Okay, if the angle of this ramp is 35, we know that that 35 comes in the top of our triangle there. Now before we go any farther, let's find the magnitudes of force of gravity in the y, and force of gravity in the x. So we'll grab a calculator. How do we find force of gravity, guys? Should be second nature by now. Mass, which is 22, times 9.8, the acceleration due to gravity. Let's round to the nearest whole number so we don't have decimals here. So force of gravity is what, guys? 216. Okay. Well, now we're going to have to use trigonometry to solve for force of gravity in the y direction and force of gravity in the x. Let's do force of gravity y first. Looks like it's the side next to. What do we call that side? Isn't it the adjacent side? So, and then we have the hypotenuse. So which trig function should we use? Cosine. Cosine. So we're going to do cosine of 35 is equal to adjacent, which is force of gravity in the y, divided by the hypotenuse, which we just solved for, which is 216. Okay, so by timesing both sides by 216, you're going to come up with this equation. 216 times the cosine of 35. Rounded to the nearest whole number is what, guys? 177? 177 newtons. I'm going to put that in down here. 177 newtons. Okay, now let's find FGX. FGX looks like it's the side opposite. So what trig function is opposite over hypotenuse? That would be sine. So sine of 35 is equal to opposite, which is FGX, divided by hypotenuse, 216. Okay, by timesing both sides by 216, we get this. Did you guys get 124? Okay, 124 newtons. Okay, I don't have much space here, but I'll try and write it. 124 newtons is FGX. Okay, now that we got all the trig done with that triangle, the rest of it's pretty easy. Guys, is block A, is it moving in this direction? No, it's at rest in this direction. So that tells us from Newton's first law that the forces have to be balanced. If we've got, what was FGY? 177? 177 newtons down, what does the normal force have to be? 177 newtons. The forces have to be balanced for it to be at rest. Okay. All right, now let's draw in the other forces that we know. What is the force that's pulling block A down the ramp? FGX, that's the force of gravity in the x direction, because this triangle right here, this FGX side, is parallel to the ramp. So we know that FGX is pulling it down the ramp. That was 124 newtons, so I'm going to put that in. 124 newtons. Okay. There's a force that's in this rope here. What do we call this force that's in the rope? That's tension. I don't know what it is yet. We'll be able to solve for it later, but for right now we're just going to put T. Now there's one more force acting on block A. What is it? Friction. But
don't know who it is yet because we don't know where it's moving.
Perfect, yeah. We don't know if it's going to point up the ramp or down the ramp because we don't know which way block A is moving, do we? So let's hold off on force of friction for just a second, but we need to remember to come back and put it in because that will definitely be a force that we need. Okay, let's go to block B now. Block B is simple. Hey, where should we start? Force of gravity is straight down, right? And that's equal to mg. So what is 18 times 9.8? Say it louder. What was that? 176.4. So should we just say 176 newtons? Anyone else get that too? Okay. 176 newtons down is force of gravity, also known as its weight. What do we call this force in the rope? That's tension. We don't know what it is yet. Okay, and that's it for B. That one's simple because there's no angles. There's no trigonometry. Okay, when you get to this point, I want you to compare two numbers. The weight of the one that's hanging, in this case it was block B, and FGX of block A, which was 124. Which way is this going to move, guys? Yeah, now there's a net force, and that net force is pulling down here. So isn't it going to pull block A up and then down? Okay. So let's get our sign notation from that. So I always put acceleration is positive when the system moves up and down like this. So as block A moves up, that's going to be positive. As it moves down, that's going to be negative. Block B, though, is going to be positive when it moves down, negative in the up direction. Okay. So there's our sign notation. That's going to be very important. Now that we know which way it's going, can we go back and put friction in on block A? Yeah, if block A is moving up, which way is friction going to point? Down. Okay. So it's getting a little messy down here, but let's see. Draw a larger arrow. So force of friction, and that's going to be equal to, can we solve for it yet? Yeah, we have the coefficient of friction, so force of friction is equal to mu times the normal. Okay, mu is 0.25, and the normal force was 177. Sandoval, what was that?
44.
44? 44 newtons, okay? Let's put that in over here. Force of friction. Okay. Now, when you get friction in, if you take friction, which is 44, and add that to FGX, which was 124, what do you get? So 124 and 44, 168. Is block B still going to have enough? Is there still going to be a net force that's going to pull block B down?
Yeah.
Yeah, because block B's weight is still greater than those two forces. And so this system will move. Okay? If you were to let go of these two blocks, it would definitely move up the ramp and then down. Okay? So now we can solve the question. It says, find the acceleration of the system and the tension in the rope. Whenever you see the word acceleration, you should think Newton's second law, which says force net is equal to ma. Okay? We're going to do it just like we did with the pulleys and have two parts to this question because we have two unknowns. We don't know tension and we don't know acceleration. So here's how we'll do it. For this first one, let's pick block A. It's more complicated. Okay? What was positive, tension or force of gravity and friction? Tension was positive, so we're going to put tension minus FGX was 124. But we're also going to have to subtract off friction, which was 44. Okay, that will give us the net force on block A. That's equal to its mass. Block A's mass was 22. And we don't know its acceleration. Okay. So let's create another equation, number 2. And that's going to be from block B. What's positive? The force of gravity down or its tension up? Well, we said everything down was positive, so 176 is going to be positive. Subtract off everything up was tension. It's going to be equal to its mass, which was 18, times its acceleration. And now we have two equations, two unknowns, and if you get to this point, tension should always cancel out. So we have a positive tension minus tension. Those cancel out. So we've got 176. Let's grab a calculator. Positive 176. We're going to subtract off FGX, which was 124. And we're also going to subtract off friction. So you should get 8 is equal to, what's 22 plus 18a?
40.
Exactly 40a. Okay, now how do we get a by itself, acceleration by itself? Divide by 40. So 8 divided by 40 is equal to 0.2. And its acceleration, so what are my units? Meters per second squared. Okay. So there's the first part of what this question was asking us. We found the acceleration of the system. If you were to let go of block A and B, it would accelerate in this direction at 0.2 meters per second squared. Okay, now we've got to find the tension in the rope. Okay, this is where we go back, we take our acceleration now that we have it and plug it in either in equation number 1 or 2 and solve for it. Okay, so I always like to pick where tension is positive, so I'm going to redo this up here. So tension minus 124 minus 44 is equal to 22 times, now we know what acceleration is, 0.2. So 22 times 0.2 is 4.4. And we're going to have to add 124 and 44 to both sides. So let's just add that, plus 44 and plus 124. So are you guys getting that tension is equal to 172.4 newtons? Okay. That's always a good idea once you have that to put it in for tension right here, 172.4 newtons. And this tension is 172.4. And ask yourself, is the block, if this is your tension and this is your weight, is it going to move down? And the answer is yes, because this one's greater. Okay? And if you added up 144 and 124, that's 168. It's still less than tension, so it will move up. Anyway. Okay, a lot of stuff going on, right? We're combining inclined planes with pulleys, and that's a good example problem. What I've got for you now is a practice problem, number 18. I would like you guys to try this one on your own. Okay? Go through, complete your free body diagram, label all the forces, find their magnitudes, and then answer the question. It says, we want to find the acceleration of the system and the tension in the rope, just like the example problem. So if you're watching the video, please hit pause right now. Try it on your own. Once you have your answer, hit play and see if you got it right. Okay, so I went ahead and filled in the free body diagram up to this point. So if you're watching the video, hopefully your numbers kind of mirror mine. But I wanted to stop at this point because this is where the problem gets a little bit tricky. So there's FGX that's pulling block M1 down the ramp this way. That's 17 newtons. We've got the weight of block M2, and that was 7.35 newtons. So you should always get to this point and compare those two numbers, because that's going to tell you which way this system is going to move. There's a net force, and it looks like the FGX of M1 is greater than the weight of M2. So we know that this system is going to move this way now. So it's going to come up and then down the ramp. So I'm going to say that everything up over here is positive and everything down is negative, because my acceleration is positive when it comes up. But over here, my acceleration is going to be positive when it comes down the ramp and negative when it goes up the ramp. So we've got to get our sign notation right. And also, don't forget to go back and put in friction. Now that we know there's going to be some friction here, right? Between M1 and the ramp. Now that we know that the block is moving down, which way should we draw in friction? Friction always opposes motion, so I'm going to draw in my force of friction this way. Okay? And we can actually solve for it. We know that force of friction is equal to mu times normal. It gave us the mu as 0.25, and the normal force was 29. So I'm getting that the force of friction is 7.25 newtons. Okay, so I'm going to put that in right here, 7.25 newtons. Right. Now we've got all the forces labeled. We don't know what tension is though, and we don't know what the acceleration of the system is. So we've got two unknowns. That means we're going to have to use Newton's second law twice to come up with two equations to solve for it. So if we're going to solve for acceleration, we're going to use Newton's second law, which says F equals ma. And this is always net. F net is equal to ma. Okay, let's make two equations here. For equation 1, I'm going to focus on this block, M1. Okay? We said that everything down the ramp was positive. So this FGX is the only force that's coming down the ramp. So 17 then we're going to subtract off everything that's going up because we said everything up is negative. The force of friction is 7.25. And we also got to subtract off tension in the rope because that's going up the round. And that's going to be equal to the mass, which was 3.5, times the acceleration. Okay. Now let's go and figure out our other equation from M2 here. We said that everything down was negative and everything up was positive. So now tension is positive, and we're going to subtract off the weight, which was 7.35. And that will give us the net force, and the net force is equal to its mass, 0.75, times the acceleration. So if we take those two equations and we add them together, your tension should always at this point cancel out. So tension minus tension cancels out. So now we've got 17 minus 7.25 minus 7.35. So grab your calculator. And you should get 2.4 is equal to 3.5a plus 0.75a. And that's 4.25 times a. To solve for a, we're going to divide by 4.25 both sides. Over here it cancels out, so 2.4 divided by 4.25. And we get that acceleration is equal to 0.56 meters per second squared. Okay, how many of you guys got that? Good. But we're not done, are we? We've got to solve for tension in the rope. Now, this is the easy part. It doesn't matter, again, which one. I always like to plug it back into where tension is positive. So I'm going to put it in equation number 2. Find some spot on the board where I have some more room. Let's do it right here. So tension minus 7.35 is equal to 0.75 times A. And we know what A is now. It's 0.56. So I'm going to plug that in. Okay, so 0.75 times 0.56, 0.42. So tension minus 7.35 is equal to 0.42. To get tension by itself, I'm going to add 7.35 to both sides. So tension is equal to 7.77. And what are the units for tension? It's a force, so that's newtons. Okay. Again, I like to put it back over here. If tension was 7.77, would this block move up? And the answer is yes, because there's a net force. This is greater than the weight, so it's going to move up. Okay. And so that does make sense. Okay, very good. I've got one last practice problem for you. Let's go there now. Practice problem 19. Now this one's a little different because now both blocks are on an inclined plane. Block A, though, is at 60 degrees. Block B is at 45 degrees. So you're going to draw your triangles. You're going to put in all your forces. And you're going to compare the forces, see which way it's going to move. Draw in your arrow for the movement. We've done this, okay? Try this. If you're watching the video at home, go through, fill out your free body diagram, and see if you can get this one correct. Again, we're solving for the acceleration of the system and the tension in the rope. So please hit pause, try it, see if you can get it right on your own. Okay, so I've gone ahead and filled in the free body diagram for both block A and B, and hopefully if you're watching the video, your free body diagram looks like this. And then I put the magnitudes in as well. So I've solved for all the magnitudes of those forces. But I stopped right here for a reason. I haven't got friction in there. But both of these blocks are going to be experiencing some friction between the inclined plane and the block. But in order to draw in friction, I really need to know which way the system is going. So let's compare two numbers. let's compare the FGX of block A, which is 85 newtons, to the FGX of block B, which is 139 newtons. And that tells us which way the system's going to go, right? Which way is it going to go, guys? Yeah, this one's so much greater. This system is going to come up on the left side, and it's going to come down on the right side. So I always put acceleration is positive when it moves that way. So now we can get our sign notation. On the left, as it moves up the ramp, that's going to be positive. That means as it moves down the ramp, that's negative. But on the right side, as it moves down, that's going to be positive, and that when it comes up is negative. Okay, so our sign notation is very important. Now we know which way it's moving, we can draw in the friction. If block A is moving up, which way is friction going to go? It's going to come down. It always opposes motion, so force of friction comes down. Let's solve for it. Force of friction is equal to mu times normal. It told us that the mu, the coefficient of friction, was 0.15. Was that for both blocks? Yeah, 0.15. So, force of friction is equal to 0.15 times the normal force on block A was 49. Okay. So 0.15 times 49. So force of friction here is going to be 7.35 newtons. I'm going to put that in right here. 7.35 newtons. Okay, now let's go over and solve for friction on block B. If block B is moving down the ramp, so which way should friction go? Goes up the ramp. Force of friction is going to go up because it's opposing motion. Okay, again, let's solve for it. I'm going to solve for it over here again. Force of friction is equal to mu times normal. Our mu is 0.15. Our normal on block B is 139. And I'm getting that force of friction is equal to 20.9 newtons. 20.9 newtons. So I'm going to put that in right here. 20.9 newtons. All right. Now that completes all the forces that we can figure out up to this point. Now we're going to go ahead and use this system and solve for its acceleration. Whenever you see the word acceleration, you should think Newton's second law, force net is equal to ma. But we don't know what tension is, and we don't know what acceleration is. So we're going to have to come up with two equations. Okay, for the first equation, move down a little bit. In this first equation, I'm going to pick block A. We said that everything up was positive. So tension is going to be positive in block A. Now to get the net force, we need to subtract off everything that's negative. So everything that's negative is F, force of gravity in our x direction, which is 85. So we're going to subtract off 85. But also, friction is pointing down, so that's negative as well, 7.35. So we're going to subtract off 7.35. That will give us our net force, which will be equal to the mass, which is 10, times the acceleration. All right, one equation, two unknowns. We must come up with another equation in order to solve this. So let's go to block B. I said that everything down on block B was positive. So now my force of gravity in the x is positive. That's 139. And I'm going to subtract off everything that's going up because we said that was negative. So tension was going up. And also force of friction was going up, which was 20.9 newtons. 20.9. And that's going to give us our net force, so we can set that equal to its mass, which was 20, and the acceleration, which we don't know, so I'm calling it A. Okay. When you get to this point, your tension should always cancel out positive tension minus tension. Okay? Tensions are gone. Now let's solve it. We've got positive 139, negative 85, and a negative 7.35, and a negative 20.9. So 139, let's subtract all of those. Did you guys get this? Did you get 25.75? Can anyone verify that?
Yeah.
Okay, perfect. Is equal to, what's 10a plus 20a? That's going to be 30 times a. Okay, to solve for acceleration, we've got to get rid of this 30, so let's divide both sides by 30. And I'm getting that my acceleration of this system is going to be 0.86 meters per second squared. Okay, anyone get that? Okay, very good. Now we just got to do one more part to this question. We've got to solve for tension. I always like to plug it back in to one of these equations, but I like to plug it in where tension is positive. So I'm going to go back into the top equation here and do it right here. I'm going to move this equation up to the top left here. So tension minus 85 minus, I'm getting it from right here, 7.35 is equal to 10 times acceleration. And since we know what A is now, it's 0.86, I'm going to plug that in. 0.86. Okay, so 10 times 0.86 is 8.6 is equal to t minus 85 minus 7.35. So to get t by itself, I need to add 85 and 7.35 to both sides. So 8.6 plus 7.35 plus 85. And my tension is 100.95 newtons. We could round that up. So let's just say tension is equal to 101 newtons. Did I do that right? Did anyone else get that?
I got 121.
Okay.
Well, I didn't round, so I got it 1.1 off, so.
Yeah, if it's just a rounding issue, if you're close to 100 or 101, I think that'll be close enough. Now, let's make sure that makes sense. If tension was 101 newtons, would there still be a net force going down here? We got 101 plus 20.9. Yeah, there's still going to be a net force going down. And if this was 101, would there still be a net force going up? What's 85 plus 7.35? Yeah, there's still going to be a net force going up. So that tension makes sense. Okay. All right, guys. Good news. We've learned enough to do a worksheet in your student workbook. This worksheet is called Pulleys and Inclined Plane Worksheet. Please go there and complete the Pulleys and Inclined Plane Worksheet now, and hopefully this video helped.